There are other features that are in our solar system: comets, asteroids, meteorites. So let's spend a few minutes talking first off about comets. These have been observed for centuries, and there has been an awful lot of superstition that has gone with comets, because the idea was that the background of stars were fixed and unchanging. That's an idea left over from Aristotle. And then through that fixed heaven, periodically you would see something that looked like this. This is an actual photograph of a comet. And these things were different and they were unusual, and they were considered prophets of doom. This is the Bayeux Tapestry from 1066, and in it there is a image of Halley's comet, and that was believed to be like something bad is a-comin', and it happened about the time when William the Conqueror came to England and actually killed King Harold. So for some people it turned out good, for some people not so good, but there's a lot of superstitions that have surrounded comets through the years. One of the first people who actually made sense out of comets of what they were was Sir Edmund Halley. Now, Sir Edmund Halley was a dear friend of Sir Isaac Newton. Actually, Halley was the fellow who paid for Newton's works to be published. Newton didn't have any money, and Halley believed in Newton so much that he said, I will pay for the printing, and if you get a chance to pay me back later, great. And I think that eventually did happen. But why do we have the most famous comet in the world named after Sir Edmund Halley? Well, he is the one who figured out that it's not a different comet. It was the same comet coming back again and again and again. And the thing that makes it more complicated is it doesn't appear on a regular basis as far as exact timing. Halley's comet returns every 74 to 79 years. Edmund Halley looked back at the records, the astronomic records, and he looked at comets from 1531, 1607, 1683, and he said, it's not a different comet. It's the same comet. It has exactly the same orbit. You see it in the same parts of the sky, but it just keeps returning. So he figured out that comets themselves were just things that had very weird, crazy, wild, and wacky orbits. Halley's comet was visible last here in 1986. Those of you who live till 2062 have a chance of seeing Edmund Halley's comet one more time. Now, what exactly makes up a comet? They're odd creatures. They do not contain a lot of rock. As a matter of fact, they contain lots and lots of ice and lots of water. Back in the 1950s, there was a gentleman from Harvard University, and his name was Fred Whipple. And Dr. Whipple came up with a theory, and it's called the dirty snowball theory. And his idea was that a comet is like a big dirty snowball that you're going to find in midwinter someplace, made of lots of ice, and mixed inside of it, there is going to be some rock and dirt and debris. Now, because it is so cold in space, it's not just water ice. It's also going to be solid carbon dioxide, solid ammonia, and solid methane. These comets have huge and very elliptical orbits. So most of the time, most of their life is spent in far, far reaches of the solar system where it's very, very cold. And these icy balls of snow are going to be, first off, very hard to see. It's very hard to actually detect a comet. They're small. They are covered in dust, so they have a tendency to be relatively dark. And they don't have the bright tails that they acquire as they get closer to the sun. Now, Kepler's third law, if you recall that, says that as an object gets closer to the sun, it's going to go faster. So most of a comet's life is going to be out here where it's cold. It's going to move very, very slowly, and that's where it's going to spend most of its time. But on this extreme elliptical orbit, a lot of these have an eccentricity of about 0.95, which is a very elliptical orbit. A straight line, if you remember, is an eccentricity of 1. So very, very, lots of ellipticalness. As they fall towards the sun, they start to warm. And that warming causes the gases in the snowball, the water, the methane, the carbon dioxide, to change directly from a solid to a gas in a process that is known as sublimation. Now, you're familiar with sublimation. You've seen it a couple different places. One, if you have ever messed around with dry ice. Now, when we say dry ice, basically we're talking about solid carbon dioxide. It's popular to get solid carbon dioxide around Halloween, and people put it in punch bowls. It makes the punch really crazy cold, but it gives you this wonderful vapor everywhere, and it looks very witchy and kind of spooky. The other place you're familiar with sublimation is your ice cubes. If you don't use your ice cubes very often, what will happen is they will appear to evaporate. Well, how the heck do ice cubes start to evaporate when they're in the fridge? Periodically, you have high energy molecules in that ice that have enough energy, individual molecules, to escape from the ice cube and actually turn into a gas. It's a very, very slow process, but that slow process is why you get sometimes weird, crazy ice cubes that look like this. Well, in the comets, the solid ice when it gets warmed by the sun, it starts to change directly from a solid into a gas, and it never actually gets warm enough to turn into a liquid in between. This is a lovely collection of pictures of a comet. As it begins to get warmed by the sun, it starts to off gas, meaning emit some gases, and it looks a little bright as that occurs. As it gets closer to the sun, it gets a little bit brighter, more gas is emitted. Closer and closer to the sun, lots more gas is emitted. And here, of course, is a more detailed picture. Now, why do I have a picture of a potato? Because of the fact that these comets have odd shapes. They are not pretty and round. Most of them are wacky shaped. So if you think all the weird shapes you get out of potatoes, same sort of thing you are going to see in the shapes of comets. Comet anatomy is going to consist of a variety of different parts. There is a nucleus. Now, the nucleus of the comet, that is going to be very, very small when you see a comet in the sky, and that is going to be the dirty snowball. That's the solid bits in the center. That's right down in there. As that dirty snowball gets hot, it is going to start off-gassing, and the gases emitted by that are going to glow bright. And you're going to have a bright, glowing region around that, and that is known as the coma. This is big. Comas can be as large as the distance from the Earth to the Moon. That's why we can see them from a great distance. Once they start to give off these gases and create comas, these are big features. They're not big structures, but they're big features. There's a lot of gas given off, and it looks quite bright. And then behind it blows two different tails. A dust tail that has a tendency to go straight back like that, and an ion tail. And the ion tail is much more colorful, and it goes off to the side. Now, why does it have these two different tails, and why do they separate? Well, the dust tail is going to be the big one. These are dust released by the comet. Remember the dirt in the dirty snowball? A lot of that dirt is going to be in the form of just plain old ordinary dust. The dust tail flies straight back because of the sun's light pressure. There is solar wind that is emitted straight away from the sun, and the dust tail is going to go backwards away from the direction of that solar wind. The ion tail, if you remember from your chemistry, ions are atoms that have a charge on them, either positive or negative. These are going to interact with the solar wind in a slightly different way because of magnetism. And when these charged particles that are ions interact with the magnetic field produced by the sun and other planets, they don't go straight back, they go back at a curve. So that's why they have two different tails. The dust tail, which is the large, bright one, and then the colorful sideways tail, and that is that ion tail. The other thing that's wacky about comet tails is the comet tail always points away from the sun, no matter the direction it's moving. So let's say that we have a comet that is moving in this sort of a path. It makes sense mentally as it's approaching the sun that the tail is going to fly backwards, sort of like if you are running and you're running very, very quickly, your hair is going to fly back behind you because of the air that you're running through. but it's the solar wind that is actually blowing those tails backwards. Here's the weird and crazy thing. As the planet is moving away from the sun, it is actually flying into its tail. And it's flying into its tail because of the fact that it's the solar wind that's blowing the tail back. And this is just weird looking. It's kind of like if you were running in this direction and your hair, and you're running very fast in this direction, and your hair, instead of flying backwards, your hair was flying in front of you. Yeah, so that's why it's always a little weird to think of, but it is the solar wind that's pushing those particles backwards. Where do comets come from? Well, we're going to talk about these two features in the next video. We will see you then.